Hello everyone, I'm Farhad from EGC section. In today's video, we are going to talk about polymorphism in Python. Let us first see what is polymorphism. It defines the ability to take different forms. Polymorphism is taken from Greek words poly means many and morphism means forms. It means that the same function name can be used for different types. Polymorphism in Python allows us to define methods in the child class with the same name as defined in their parent class. How are child class and parent class used and how is polymorphism defined? Let's see further. A child class inherits all the methods from the parent class. However, in some situations, the methods inherited from the parent class doesn't fit into the child class. In such cases, we have to re-implement the method in the child class. Function polymorphism. We have two types, inbuilt polymorphic functions and user-defined polymorphic functions. Let's first see what are inbuilt polymorphic functions. These are the functions which are already there in the program. Let us see a program to demonstrate inbuilt polymorphic functions. Here, let's take len. Len is being used for a string, print of len of geeks. Again, len is being used for a list, print of len of list 10, 20, 30. And here is the output. Len is used to define a string, list, or even a dictionary. User-defined polymorphic functions. User-defined functions are those which are defined by the user, which are not there in the program. Let us see a simple function to demonstrate polymorphism. Def add x comma y comma z is equal to 0 and then return x plus y plus z. Print of add of 2 comma 3. Print of add of 2 comma 3 comma 4 and here is the output. Polymorphism with a function and objects. We can create polymorphism with a function that can take any object as a parameter and execute its method without checking its class type. Using this, we can call object actions using the same function instead of repeating method calls. Let us take a program to understand the polymorphism with a function and objects. Let's first create a class Ferrari. Define fuel underscore type and print petrol. Then define max underscore speed and then print the maximum speed is 350. Again, create a class BMW. Define fuel underscore type, print diesel. Again, define max underscore speed and then print max speed is 240. In normal functions, we define def car underscore details of object. Object dot fuel underscore type. We are here calling the functions so that we can get an output. Object dot max underscore speed. Ferrari and then let's get the car details. Car underscore details of Ferrari and then car underscore details of BMW and here is the output. In this program, polymorphism is taking place by using the functions twice and creating the classes. Polymorphism with class methods. Here, the below code which we have used shows how Python can use two different class types in the same way. We create a for loop that iterates through a tuple of objects, then call the methods without being concerned about which class type each object is. We assume that these methods actually exist in each class. Let us see the program. First, create a class India. Then define the capital. Print the capital is New Delhi. And then again define the language. Print Hindi and English are the languages. Again, define a class USA. Define capital and then print the capital of USA is Washington DC. Define the language. then print English. Here is the execution part. By calling the function, we can get an output. Object underscore int is equal to India. Object underscore USA is equal to USA. For country in, let's create a for loop. For country in object India and object underscore USA. Let's call the capitals country dot capital and then the language country dot language, and here is the output. Let's see how polymorphism is used with inheritance. It defines the methods in the child class that have the same name as the methods in parent class. In inheritance, the child class inherits the methods from the parent class. Also, it's possible to modify a method in the child class that it has inherited from the parent class. This is mostly used in cases where the method is inherited from the parent class and doesn't fit in the child class. The process of re-implementing a method in the child class is known as method overriding. In this picture, let's first see how inheritance is used. Human, we are humans. And let's take a father and a mother. And then from them, we get a son. Let's see a program. First, create a class bird. Then define intro and print there are different types of birds. Again, define flight of self. Print most of the birds can fly, but some birds can't fly. Class, create a class parrot. Again, define flight. Print parrots can fly. Again, create a class called penguin. Define flight. Print penguins do not fly. Here, bird is a base child class, and then we are again reusing the bird in the further classes. So here inheritance takes place and polymorphism takes place by flight functions. And here is the execution part. By calling the function only, we can get the output. Object underscore bird is equal to bird. Object underscore parrot is equal to parrot. Object underscore peng is equal to penguin. Let us call the child class. Object underscore bird dot intro is the child class. Let's call the main function used. Object underscore bird dot flight. Now let's call the other two classes which we have created using bird. Object underscore par dot intro, object underscore par dot flight, and then object underscore peng dot intro and object underscore peng dot flight. And here is the output. They are different types of birds. Most of the birds can fly, but some can't. We get all the outputs which we have given. Polymorphism allows us to access these overridden methods and attributes that have the same name as the parent class. Let us see a program how to override the methods. Let's import math. Class shape. Def of init of self comma name. Init is a built-in function. Self dot name is equal to name. Let's define the area of self. Then pass the function. Again define fact of self. Return I am two-dimensional shape. We are returning def of str of self, returning the self name. Class, again create a class square, which is a shape. Def of init of self comma length. We are using the super method to define init of square. Self dot length is equal to length. Again, define the area of square. Return the self length and then define fact of self. Again, return squares have each angle equal to 90 degrees. And here is the output. The shape is circle and we have two-dimensional shape. Squares have each angle equal to 90 degrees and this is the area. Let us conclude polymorphism. It is the expression of genetic diversity of species. This gives each species flexibility of adaptation in the environment. Further, this is the population level ground for the action of natural selection, leading to change in allele frequencies and then microevolution. In this picture, we can see as example Jessa, a girl who takes an employee role, a tennis player role, and a wife role as per the situation changes. Thank you so much.